We good with that. Move on to 19. 19 is a calculator question, so we can just plug that in the calculator. So again, we're going to try to work through the odd number problems in class. Yeah, just finding the derivative of each component and then plugging in. Yeah. I just want to do the odds so we can kind of just see all the variety of problems in class. Thanks. On page 12, can we actually go through or practice going through number 24? 24 has use substitution in it. I think it's good for us to practice. Also, it's not a calculator. So I want to see us work through that. So page 12, number 24. But essentially, you're just taking the antiderivative and then solving for C, but you're doing it twice, once for the horizontal and once for the vertical component. Okay, next move on to page 13. Got a parametric motion calculator question, FRQ. Any questions? Page 12. Part D, average speed, use average value theorem. Okay, I'd like for us to, after this, skip to page 17, and let's review second derivative of Parrish equation, where we have to do that d over dt, dy dx divided by dx dt is kind of have that additional component for second derivative. So page 17, let's look at number 35. So build your dy dx first, find the derivative of that, and then divide by dx dt, and that will be the full 2y over dx2. Try 35 and 37, and then I want to do a full polar area problem with you on page 19, and then we can stop. Try 35 and 37. We'll do a polar problem. Numbers 35 and 37, page 17. Okay, any questions? Page 13. Different part B. Yeah, if it's calculator, you can plug everything in. There's no need to show any work. Oh, right. Yeah, sorry, I didn't specify all these problems, whether something is calculator or non-calculator. But I had a mixture of different types in here. All right, so try 35 and 37 on page 17. So we first have to build dy dx. So we got to get our dy dt and get our dx dt. So dx dt, we can go through e to the u times u prime, y prime also e to the u times u prime. So we get our two components, put them over each other. That's our dy dx. And then to get to the second derivative, we got to take the derivative of this and then still divide by dx dt. So this feels, I think, everything within this process feels pretty straightforward. It's just that we got to remember, oh, I got to still divide by dx dt as part of my second derivative process. Okay, try the same process for 37. But now you have A's and B's, so treat A's and B's like you would a 2 or 3, like a constant. So it's going to have to stay in your answer or in your derivative, or a lot of your terms here.
Formula sheet at all?
The only formulas that they give you will be for geometric shapes, like for related rates. Yeah. But they won't give you any derivative or interval formulas. Okay. I'd like for us to see if we can walk through page 19 together. Okay, here's page 19. Or just give me 5 minutes. All right, so it says the figure, this is page 19, the figure shows the graph of polar graph, r equals 1 minus 2 cosine theta. That's this curve here. And the unit circle r equals 1. So we have a unit circle here. Part A says find the area of the shaded region in the figure. So here's the shaded region. You see, if you look at the shaded region here, shaded region, we got definitely a full quarter circle, but then we have to basically figure out what portions of the other quarter circles are missing. So one strategy is, why don't we think of it this way, where it's basically a 3/4 circle minus whatever these gaps are in this region. And I took that graph and I just kind of zoomed in. And basically, if we can just do 3/4 circle minus these regions, and that will give us the area that we're looking for that shaded region. Okay, so part A here. Area of the shaded is equal to the quarter circle minus the area using our polar curve formula. Okay, so let's do the easy part here. Area is going to be 3/4 pi r squared minus whatever it takes for us to figure out this region here. Again, it's the same region here. I'm just zooming in so we can kind of see a little bit better. I think it helps to know how the graph is moving. This is to know that, okay, if we can create a table of values, we should be able to get an indication as to, where's the graph starting? Is it starting here? Is it starting here? Is it starting over here? So if I start at theta equals 0, and here's my polar curve, r equals 1 minus 2 cosine theta. Okay. If I plug 0 in for theta, I get 1 minus 2 times cosine 0. So that's 1 minus 2 times -1. Sorry, 1 minus 2, which is -1. The cosine of 0 is 1. So radius is -1. So that means at 0, along the 0 line, my 0 degree is to the right, but then my radius is -1. So I'm going to start over here. So this is my starting point. This is the start of my curve or my graph. Okay. So it's going to start at 0. And if we just plug in some values to kind of see, where is the graph going? At pi over 3, we get 1 minus 2 times 1/2, which is 1 minus 1, which is 0. So that means at pi over 3, it's going to get to this polar 0, right? So pi over 3 is going to hit that polar 0. And if we make it keep going here, what about at pi over 2? I'm just picking easy unit circle values for me to kind of help me figure out where my graph is. At pi over 2, cosine of pi over 2 is 0. 1 minus 2 is, is 0. So 2 times 0 is 0. 1 minus 0 is 1. So at pi over 2, we end up over here. And that helps us close off our gap, right? So the area that will be created, remember, all area of polar starts with a polar 0 and it extends out, it fans out to the curve. So from 0, it's going to start accumulating like this, right? All these sector regions coming out like this. And then after this, it's going to keep going. Until it gets to pi over 2. So our area formula for that region will just be 1/2 definite integral from 0 to pi over 2 r squared d theta, and we know r is our 1 minus 2 cosine theta squared d theta. I think on the test, I think students had trouble figuring out, they know what formula to use, but they didn't know what the bounds were, or they didn't know how the area was accumulated. So I just want to go through a full example. We'll spend a full class tomorrow just with polar graphs, because with polar, the calculus is not the issue, right? If we have the formula, we just plug it in. The issue is, knowing where the graph starts, knowing where it ends, how the graph is being formed, and being able to have enough information to use the formula. So part A ends up just giving us, the radius of this quarter circle, or of the circle, is 1. So 3/4 is pi r squared, pi 1 squared, minus 1/2 integral from 0 to pi over 2, r squared d theta, and then decimal value, that gets us down to 2. Okay, part B. Find the slope of the line tangent to the polar curve, r equals 1 minus 2 cosine theta, at the point where x equals -2. Show the computation that leads to your answer. So the slope, we're going to find dx over d theta versus dy over d theta. And then from both those components, we can put them over each other to get our slope. So we know that x is r cosine theta. We know y is r sine theta. So we can build our x and y in terms of theta. But the good thing is that, once we have our x equation, we can just plug in the calculator to get our dx d theta. Sorry, at x equals -2. So we actually had to graph this and actually find that x-intercept. Now, even though this is in terms of theta, I would suggest that you just do everything in terms of x and y, and then just plug this in the calculator in terms of x and y. bring everything over to one side, set equal to 0, find that x-intercept, and that x-intercept will just be 2.4667. And then you just do dx over d theta and dy over d theta separately. You can do math 8, evaluate the derivative at those points. And then once you get those slope components, your y prime and your x prime, divide them over each other, and that's your slope. And then for part C, there's mentions of d theta over dt and dr over dt. So that should be an indication or a reminder that we're having to go through related rates. So related rates, everything, if we want d over dt to show up, we got to go through related rates. So r becomes dr dt, 1 goes to 0. Cosine of theta becomes negative sine theta d theta dt. And now we can use the values that they give us to help us find that missing piece, which is dr dt. All right, so your homework to finish pages 9 through 19. We kind of just did selected problems over those pages, but you guys can finish those pages. And then tomorrow we'll finish the rest of the packet, but we'll go through each problem more slowly. I know polar requires a little bit more review, so we'll spend all class period tomorrow just going through all the polar problems in the rest of our. All right, complete your phones. Yeah.
Oh, in my case, I did such a case back.
Yeah, you can put that and then plug yours. Either I'm like,
Yeah, it's.